Hi, I'm Mindy from Apex Tutoring. Today we'll be working through the 2022 HSC Mathematics Standard 2 exam. I'll be assisted by the brand new Casio FX8200AU. Let's get started. Okay, question 1 says, which graph represents a negatively skewed distribution? So a negatively skewed distribution will have the peak on the right and its tail on the left. It's kind of the opposite of what you might automatically think. So just remember what I tell my students is to look at the side with the tail on it. If you look at the options here, option C has its tail on the left side. So the correct answer is C. Okay, question 2 is about linear relationships. It says, which of the following could be the graph of y equals minus 2x plus 2? So to answer this question, we'll have to identify the gradient and the y-intercept. Now the gradient is the coefficient of x, the number in front of x. In this case, it's -2. The y-intercept is the constant term. In this case, it's 2. Now if we look at our options, we're looking for a graph that has a negative gradient and a positive y-intercept. If we look at options A and B, those are the ones with a negative gradient. From those, option A is the one that has a positive y-intercept. So the correct answer is A. Okay, question 3 is about critical path analysis in networks. It says the network diagram shows the time needed for each step in order to complete a project. It says, what is the critical path to complete the project? If we observe the network diagram, we can see that a forward and backward scan has already been completed. And so, as long as we know that the critical path follows the vertices where the earliest and latest start times are the same, we can find the critical path. And so that would follow along A, D, and G. And so the correct answer is B. Okay, question 4 is about a sampling technique, but it is typically solved with ratios. It says Lily wants to estimate the number of fish in a lake. She randomly captured 30 fish, then tagged and released them. 1 week later, she randomly captured 40 fish from the same lake. She found that 12 of these 40 fish were tagged. What is the best estimate for the total number of fish in the lake? So this is the capture-recapture technique. What we're trying to work out is the total number of fish in the population. If we call that P, we can set up ratios where we have total and tagged. So in the population, there is a total of 30 tagged fish. My ratio would be P over 30 if I put P on the top, total, and tagged on the bottom, which is 30. Now that's going to be the same as the ratio of total to tagged in the sample, which is 12 in 40. Now be careful because I'm putting the total in the top of this ratio, so I have to do the same for the second ratio. The total in the sample is 40. The tagged is 12. These ratios are equivalent, so I can just solve for P. All I need to do is multiply by 30. All right, so we'll work that out. 40 over 12 times 30 is 100. So the answer is D. Okay, question 5 is a statistics question. It says, consider the following data sets. We have a list of 6 scores, and it says which row of the table shows how the median and mean are affected when a score of 5 is added to the data set. Let's first take a look at what happens to the median. So currently, the scores being in order, we'd have the median between the middle two scores, which would be 17. Now, if we add a score of 5, which is lower than the rest of the scores, it would be over here. And the new median would be located at the middle score, which would be 17. And so adding the 5 into the scores does not actually change the median in this case. Now let's talk about the mean. So the mean, or the average, takes every data point into its calculation. And so if you put a new score into a data set, it will change the mean unless that score is equal to the mean. Now, 5 being lower than the rest of the scores is definitely not going to equal the mean, and so we're guaranteed it's going to have an effect on it. So the correct answer will be D, which says that the median will actually stay the same, but the mean will change. All right, question 6 is a ratio question. So it says, what is 20 minutes to 1/3 of a day, expressed as a ratio in simplest form? We'll start by writing what we're given. 20 minutes to 1/3 of a day. But ratios are meant to have the same unit on both sides. So first we're going to convert. Now I usually go with converting the larger unit into the smaller unit because typically then I can avoid decimals and fractions. So 1/3 of a day, we'll convert that to hours. We need to work out what 1/3 of 24 is. We could do that by dividing by 3 or multiplying 24 by 1/3, or maybe you know what it is already. 1/3 of a day is 8 hours. So we'll write 20 minutes to 8 hours. Now let's convert that to minutes. Of course, there's 60 minutes in an hour, so if we times that by 60, we'll get 480. Now that both sides are the same unit, we can just write the numbers. It's 20 to 480. But we still need to simplify that. Now both of these divide by 20. 20 divided by 20 is 1, and 480 divided by 20 is 24. So the answer is B. Number 7 says, Tian is paid $20.45 per hour, as well as a meal allowance of $16.20 per day. What are Tian's total earnings if she works 9 hours per day for 5 days? So this is a question from the Money Matters topic, specifically about income. Now, we need to work out how many hours she's going to be working. 9 hours per day for 5 days. That's 45 hours. She makes $20.45 per hour, so we'll times that by 2045. To get $920.25. Don't forget about the meal allowance of $16.20 per day. For 5 days, we'll see how much that is. That's $81. So her total pay will be the sum of these two. $1,001.25. So the answer is C. Question 8 says, which true bearing is the same as south 48 degrees west? So this is a question about bearings. First, let's draw a diagram. South 48 degrees west means start in the south direction and turn 48 degrees in the west direction. So that would be about here. A true bearing has to start at north and has to go clockwise. So that would be this angle here, which would be 180 degrees from here to here, plus the 48 from here to here. That would be 180 plus 48, which would be 228 degrees. The answer is C. All right, question 9 says an object is projected vertically into the air. Its height, h meters above the ground, after t seconds is given by h equals -5 t squared plus 80t. We have its graph, and then it says for how long is the object at a height of 300 meters or more above the ground. Now, a lot of students find these kinds of questions intimidating, but they're usually easier than they seem. So notice that the vertical axis is h in meters, and we're asked for when and how long the object is at 300 or above. So let's find 300, trace it across to the graph. We can see that would be from here to here. Now, if we look down at the horizontal axis, that's the time in seconds. So from 6 seconds to 10 seconds, it is at 300 or above, which is a total of 4 seconds. So the answer is A. Number 10 says Alex purchased 800 shares. The total cost was $2.60 per share. Alex sold the shares 1 year later for $3.40 each and paid a fee of $24.95 for selling the shares. What profit did Alex make on these shares? So this question is about shares, but it doesn't have anything to do with dividends or dividend yield. It's just a profit and loss question. So Alex purchased 800 at $2.60 each. We'll work that out. So that's $2,080. And that is how much Alex spent. Now, how much did Alex make from the sale? Well, they sold 800 at $3.40 each, but they paid a $24.95 fee for selling them. So we'll subtract that from the income. That is $2,695.05. So the profit is the difference, and we'll subtract the $2,080 that Alex spent originally, which gives us a profit of $615.05. So the answer is B. Okay, question 11 says, in 10 years, the future value of an investment will be $150,000. The interest rate is 4% per annum, compounded half yearly. Which equation will give the present value, PV, of the investment? So this question requires the use of the compound interest formula, which is on the reference sheet. This one here is the compound interest formula. FV equals PV, bracket, 1 plus R, close bracket, to the power of N. Now, if we change the subject of this formula to PV, we divide by the brackets because PV is multiplied by 1 plus R to the N. So PV is FV over 1 plus R to the N. Now we need to get the information for the prenumerals on the right-hand side here. So we've seen the question that in 10 years, the future value is 150,000. So 150,000 is FV. It says the interest rate is 4% per annum, compounded half yearly. Always double check the compounding periods. R has to be the same as the compounding period. So while it is 4% per annum, that would be 2% per half year. We could get that by taking 4% divided by 2% per half year. As a decimal, that would be 0.02. If you're not comfortable converting percentages into decimals, you can put it in your calculator. For example, if you put 2 over 100, any percentage, you could put it over 100 and convert that to decimal. Lastly, we'll need n. N is the number of compounding periods. Now, this goes for 10 years, but it is compounded every half year, as in twice a year. So n will be 10 times 2, 20 compounding periods. Now, if we put all that into the formula, we'll get our answer, 150,000 over 1 plus 0.02 to the power of 20. So the answer is D. Now, question 12 says, for a particular course, the recorded data show a relationship between the number of hours of study per week and the marks achieved out of 100. A least squares regression line is fitted to this dataset. The equation of this line is given by m equals 20 plus 3h, where m is the predicted mark and h is the number of hours studied per week. Based on this regression equation, which of the following is correct regarding the predicted mark of a student? So to answer this question, we have to be familiar with linear relationships and their equations, about the gradient and the vertical intercepts, and what they mean in a regression equation. So least squares regression lines are often written in a different order than our typical y equals mx plus c. In statistics, we often write y equals a plus bx. So it's really important to remember that it's the coefficient of the independent variable that is the gradient, and the constant term, the number that's by itself, that is the vertical intercept. So in this equation, the gradient is 3, and the intercept is 20. Now, what do they mean in a context like this? So your vertical intercept is often thought of as a starting value. It doesn't always have a lot of meaning in least squares regression lines. However, it does make sense in this one if h is 0. Now, h being the number of hours studied, if someone studies 0 hours, what would we expect their mark to be? If h is 0, you would just get 20. So you can see that as a starting value, that the marks would start at 20 when h is 0. The gradient is then how much it increases or decreases from that point. Since we're adding 3 times h, each time h increases by 1. We can look at that gradient as well, being 3 as a whole number is 3 over 1. 3 is the rise, 1 is the run. Since it's positive, it's going up 3 when I go across 1. If we were to do a quick sketch of this relationship, we'd have it starting at 20, and then it would go up 3 and across 1 for the gradients. Now in this case, what was y is now m, the predicted mark, the dependent variable is on the vertical axis. What is usually the x variable is now h on the horizontal axis, which is our independent variable. And in this case, every time we go across 1, m is going up by 3. So let's look at the options and see which is the correct one. So option A says it will be 3 for 0 hours of study per week. We can check that is not true if we make h 0. Even on the calculator, you can check that you would not get 3, you would get 20. Option B says it will be 20 for 0 hours of study per week. Now, we already talked about that. You can check it on the calculator. We discussed that. If h is 0, you would get 20. It looks like B is the correct option. I still like to check all the options just to make sure I haven't made a mistake in my logic. So we might come back to B. Now C says it will increase by 20 for every additional hour of study per week. As we already discussed, it's going up by 3 for every extra hour of study. That's the gradient. But you could even check that by making H1 and then 2 and seeing how much it goes up by. We know that 20 is actually the starting value. And option D says it will increase by 1 for every 3 additional hours of study per week. That is the inverse of the gradient that we have. We know that in this equation, it's increasing by 3 for every 1 additional hour of study per week. Now, D would be correct if the gradient was 1/3, which it's not. So that confirms that B is the correct answer. All right, question 13 says a random variable is normally distributed with a mean 0 and standard deviation 1. By the way, that's what we call a standard normal. Now, the table it shows gives us the probability that this random variable lies below z for some positive values of z. We sometimes call these z-scores. Now, below the table it says the probability values given in the table are represented by the shaded area in the following diagram. So this is the typical setup for a standard normal table where we're given the probability up to a given z-score. Then it says, what is the probability that a normally distributed random variable with mean 0 and standard deviation 1 lies between 0 and 1.94? Now, in this case, the standard normal, the mean is 0, and that's what we have in the center. And 1.94 is in the table where it says that 0.9738, as in 97.38%, will lie below that z-score of 1.94. So if we say this is 1.94, that entire shaded area in that diagram is 0.9738. Now the question's asking us for what's between 0 and that z-score. So we're looking for this part here. Now it just comes down to knowing that since a normal distribution is symmetric, 50% will be below the mean and of course 50% above. So this down here is 50% or 0.5. So the part I colored in blue will be 0.9738 minus 0.5, which would be 0.4738, which is B. Now the next question is about changing the subject of a formula. We want to change the subject to x. So I'm going to rewrite this formula. We are solving for x, and we have a times x minus b is divided by 2, and that equals y. The first thing to do to solve for x, or to make x the subject, is to multiply both sides of this equation by 2, as that will cancel out the dividing by 2. We now have 2 times y, which we would write 2y equals ax minus b. Next, we can add b to both sides to cancel out the subtraction of b on the right-hand side. So now we have 2y plus b equals ax. Since that means a times x, we can divide both sides of this equation by a to finally get x by itself. Now remember, to divide the entire left-hand side by a by writing it in one big fraction. So we have x is equal to 2y plus b all over a, which is option A. Okay, question 15, the last multiple choice question, which is usually a pretty tricky one, says the cumulative frequency graph shows the distribution of a number of movie downloads made by 100 people in 1 month. Below the graph, it says, which box plot best represents the same data as displayed in the cumulative frequency graph? So to answer this question, we need to know what values are used to create a box plot. And that would be what we sometimes call the 5-number summary, which is the min, Q1, the median, Q3, and the max. Now, we can find those from a cumulative frequency histogram if it has a polygon or ogive drawn on it. This one already does. So first, the min and the max are the 2 and the 9. Those are the smallest and largest scores in the dataset. You'll notice that all of the options have those as the min and the max, so that doesn't help us a lot, but that's our first and last number in the 5-number summary. Next, we can find the median. The median is the middle score. Now we know that there are 100 scores, and the middle score would be the 50th. On a cumulative frequency histogram, we'll find the middle score, so in this case 50, and trace that across to the ogive or polygon to see that that would be in the 6s, right? So the median is 6. And then the quartiles are found very similarly, and a quartile is dividing our data into quarters. Half of a half is a quarter, so our lower 50 scores will split in half, so the middle of that, the lower quartile, will be at score 25, which would be here. Tracing that across, we find that is a 3. And then the upper quartile would be the 75th score, half of the upper half, which will be here, which will be a 7. So that's our 5-number summary and what we should see in our box plot. We know they all start and end at 2 and 9. So we're looking for the box starting at 3, the middle line at the 6, and the top of the box at the 7. So the correct answer will be C. All right, question 16. Tom is 25 years old and likes to keep fit by exercising. Use this formula to find his maximum heart rate in BPM. Maximum heart rate equals 220 minus age in years. Tom's maximum heart rate is blank BPM. So we're just going to use the formula 220 minus 25, which is 195. That one's a pretty easy one. The next part says, Tom will get the most benefit from his exercise if his heart rate is between 50% and 85% of his maximum heart rate. Between what 2 heart rates should Tom be aiming for to get the most benefit from his exercise? So all we need to do is find 50% and 85% of his maximum heart rate. We can do that by multiplying by the percentage. So we get 97.5. And 165.75. All right, question 17. The numbers 1, 2, 3, 4, 5, and 6 are each written on separate cards. Amy has cards 1, 3, and 5, and Bob has cards 2, 4, and 6. They play a game in which each person randomly chooses one of their own cards and compares it with the other person's card. The person with a higher card wins. Now, a partially completed tree diagram is shown. We need to complete the tree diagram and find the probability that Bob wins. So, let's complete the tree diagram. Amy could pull a 1, and then Bob could put a 2, 4, or a 6 down. Or Amy could choose 3, and then Bob could choose 2, 4, or 6. Or if Amy chooses 5, Bob could choose 2, 4, or 6. Now, if they are choosing randomly, they're all equally likely. And we just need to count the number of outcomes where Bob wins. And he wins if he has the higher card. So in this first set, all 3 outcomes are Bob winning. In the second set, it's the 4 and the 6. And then the last set, just the 6. So that's a total of 6 winning outcomes for Bob out of 9 outcomes, which simplifies to 2/3. Now in the next part, it says, suppose Amy and Bob play this game 30 times. How many times would Bob be expected to win? Well, if he wins 2/3 of the time, and they play 30 games, then we'd expect him to win 2/3 of 30. To find that, we could multiply 30 by 2/3, or we could divide 30 by 3 to get a third, and then times that by 2. The answer is 20. Okay, question 18 says, the marks in a test were normally distributed. The mean mark was 60 and the standard deviation was 15. What was the percentage of marks higher than 90? So to work this out, we need to know what the z-score of 90 is. We can look at the reference sheet if we need to. The z-score formula is here. We'll also be referencing this once we find it. So we have z equals x, which is the score, minus mu, which is the mean, over the standard deviation. Now, we're looking at the z-score for 90, with a mean of 60, and a standard deviation of 15. So the score of 90 has a z-score of 2. And it's asking what percentage are higher. So if we look at our reference sheet, we can see that approximately 95% of scores are between -2 and +2, which would be all of this here. And so the percentage that would be above would be half of the amount or the percentage that is outside of the 95%. Now, 100% minus 95% is 5%. So in these two tails, we have a total of 5%. It's symmetric, so each of them is half of that. So this would be 2.5%. And that's the answer to the question. All right, question 19. The table shows the types of customer complaints received by an online business in a month. What are the values of A and B? So if we look in the table, we have frequency, cumulative frequency, and cumulative percentage. Now, A is the cumulative frequency for delivery fee. Now, cumulative frequency is when we add up as we go the total frequencies up to that point. So yeah, it starts with 98. To get the next one, we'd add 62. 98 plus 62 gives us 160. Now, B is the cumulative percentage for damaged item. We just need to take our cumulative frequency as a percentage of the total, which we can see is 200. So to find that, we'll do 192 divided by 200, and we'll get 0.96, which is 96%. Remember to convert decimal to percentage if you need to. You can times by 100. The next part is about a Pareto chart. It says the data from the table are shown in the following Pareto charts. The manager will address 80% of the complaints. Which types of complaints will the manager address? So remember with the Pareto charts, the line graph is cumulative percentage and follows the vertical axis on the right. So if he's going to address 80% of the claims, then we would find that cumulative, everything up to delivery fee is 80%. So remember that's cumulative. That means it includes that and everything before it. So if he addresses these two items, then he will be addressing 80% of complaints. All right, question 20. The table below shows the distances in kilometers between a number of towns. Using the vertices given, draw a weighted network diagram to represent the information shown in the table. So we're going to translate the information in the table into a weighted network diagram. Let's just start on the left. So we can see that Snowtown connects to Town Y, which we can see from the top is Yuma, and they are 280 kilometers apart. So we'll draw a line to connect them. And don't forget to put the weights, 280. Remember that these types of tables, if they're not directed, are symmetric. So if we look at the column for Yuma, we'll also see it connects to town S with a weight of 280. So we've already taken care of that. Next, if we're on the left going down, we'll look at Snowtown connecting to town B, which is Boston, or Boston. And that has a weight of 275. So we'll connect them with a line. Next, we can look at Clareville connected to Yuma for a weight of 60. And Clareville connected to Boston or Boston for a weight of 150. Next, we can look at Yuma connecting to town M, Morella, 530. And lastly, Boston or Boston connected to Morella for 790. Sometimes I need to move the numbers around if they end up overlapped. And that's the completed diagram. Now we have a tourist wishes to visit each town. Draw the minimum spanning tree, which will allow for this, and determine its length. So to create a minimum spanning tree, we can use Kruskal's algorithm or Prim's algorithm. Since it's a pretty small tree, I might just use Prim's algorithm and start with the smallest weighted edge, which is 60, the one that connects Y and C. The next smallest edge is 150, which connects B and C. The next smallest is 275 to connect S and B. Now, the next smallest is 280, but we don't want to include the line that connects S and Y because S and Y are already connected into the tree. So then we'll look at the last two options. Between 530 and 790, we'll pick 530, of course, which connects Y and M. That's our minimum spanning tree. The total length, we'll just add up the edges. $1,015. Question 21. A real estate agent's commission for selling houses is 2% for the first $800,000 of the sale price and 1.5% for any amount over $800,000. Calculate the commission earned in selling a house for $1,500,000. So this is what we call commission on a sliding scale. So since the value is over 800,000, we get the full 2% of 800,000. Remember, we can find that by multiplying by 2%. 16,000. And then 1.5% on the value over 800,000. So to find that, we can do 1,500,000 minus 800,000. That will be 700,000. And then 1.5% of that. $10,500. The total commission is the sum of these two, the 16,000 and the 10,500, $26,500. Question 22. The formula C equals 100N plus B is used to calculate the cost of producing laptops, where C is the cost in dollars, N is the number of laptops produced, and B is the fixed cost in dollars. Find the cost when 1,943 laptops are produced and the fixed cost is $20,180. So, this is about using formulas. So, we're going to substitute in N and B, and so we're finding cost C when it is 100 times N, in this case, 1,943. Plus B as in the fixed cost, which is 20,180. That's 214,480. Next it says, some laptops have some extra features added. The formula to calculate the production cost for these is C equals 100N plus AN plus 20,180, where A is the additional cost per laptop produced. Find the number of laptops produced if the additional cost is $26 per laptop and the total production cost is $97,040. So this time they're asking for the number produced, they're asking for N, which means we're going to have to solve for N. The cost is given, that's C, that's $97,040. That is equal to 100N. Again, we don't know what N is yet. Plus A times N. A is the additional cost, which was said to be 26. So we'll write 26N plus 20,180. And now we have to solve for N. Before we go and do that, the best thing to do would be to combine the like terms on the right side of the equation. 100N plus 26N is 126N. Now we'll solve for N. First, we'll subtract the 20,180 . So 76,860 equals 126N. And the last step would be to divide by 126. So N equals 610. Question 23. A teacher surveyed the students in her Year 8 class to investigate the relationship between the average number of hours of phone use per day and the average number of hours of sleep per day. The results are shown in the scatter plot below. Now, part A, the data for two new students, Alenta and Barani, are shown in the table below. Plot their results on the scatter plots. So, let's look at Alenta. Her phone use was 4 hours on average per day, and she averaged 8 hours of sleep per day. So to plot that, we'll find 4 on the horizontal axis, which is the hours of phone use, And then we'll find 8 for the vertical axis, which is hours of sleep, and plot a point there at 4/8. Next, let's look at Barani. His average use of the phone was 0 hours per day, and he averaged 10.5 hours of sleep per day. Good for him. So we'll plot him at 0, 10.5, which would be here, halfway between the 10 and the 11. Now for part B, by first fitting the line of best fit by eye on the scatter plots, estimate the average number of hours of sleep per day for a student who uses the phone for an average of 2 hours per day. So when we draw a line of best fit by eye, we should grab our ruler and try to draw a line through the middle of the points. Around here is probably good. And then we can use it to estimate, in this case, sleep for using the phone an average of 2 hours a day. So horizontal axis, phone use, go to 2. And then let's go up to the line, which is about here. And I would estimate that to be about 9 hours of sleep per day. Question 24. A student believes that the time it takes for an ice cube to melt, m minutes, varies inversely with the room temperature, T degrees Celsius. The student observes that at a room temperature of 15 degrees Celsius, it takes 12 minutes for an ice cube to melt. Find the equation relating m and t. So it's important to remember that when we have inverse variation, the equation is of the form y equals k over x. In this case, y is going to be m in minutes, and x is going to be the temperature, T. K is known as the constant of variation, and we can find it by substituting in the given information that when temperature is 15, the minutes is 12 for the ice cube to melt. We can solve for K by multiplying by 15. K is 180. Don't forget to rewrite the relationship with K now substituted in. So the minutes will be 180 divided by T. Remember that T can vary. T will be whatever temperature the room is, and then M, the number of minutes to melt, will depend on T. Now part B, by first completing this table of values, graph the relationship between temperature and time from T equals 5 to T equals 30. So when T equals 5, we'll look at our equation, M equals 180 divided by T, and M will be 180 divided by 5, which is 36. When T is 15, we already know that it takes 12 minutes. We could plug it in. We're still going to get 12. And when T is 30, M will be 180 divided by 30, which is 6. As you can see, it's inverse variation. The lower the temperature, the longer it takes to melt. The higher the temperature, the quicker it takes to melt. So now we just plot these points. We have 5, 36, which would be here, 15, 12, which would be here, and 36, which would be here. The graph would look like this. Question 25. The table shows the future value of an annuity of $1. So we have a future value table. Zal is saving for a trip and estimates he will need $15,000. He opens an account earning 3% per annum compounded annually. How much does Zal need to deposit every year if he wishes to have enough money for the trip in 4 years' time? We're being given the future value, $15,000. we're being asked for the contribution. We often use A for contribution in annuities. And the future value equals the contribution times the number in the table. Now, the number in the table depends on the interest rate and the number of time periods. In this case, 3%, 4 years. So we're going to use this number here in the table. So we have the future value, 15,000, equals the contribution, which we want to know, times the number in the table, 4.184. Now we just solve for A by dividing by 4.184. So we get $3,585.09. Now for part B, how much interest will Zal earn on his investment over the 4 years? Give your answer to the nearest dollar. Now remember, interest isn't always about using a fancy formula. Interest will be the difference between the amount invested and the amount you have in the end. So Zal is depositing, as we learned in part A, $3,585.09 every year for 4 years. We want to know how much he puts into the account altogether. So we'll times that by 4. He has deposited $14,340.34. Now, he has a future value of $15,000. So the difference between how much he has deposited himself and his future value is the interest earned. So if we subtract that from 15,000, we'll get $659.66. Question 26. It's 4 marks, so that means it's one of the major questions, or there's going to be a lot to do. So the diagram shows 2 right-angled triangles, ABC and ABD, where AC is 35 centimeters, BD is 93, angle ACB is 41 degrees, and angle ADB is labeled theta. Calculate the size of angle theta to the nearest minute. All right, sometimes we call this a 2-triangle problem. We'll have enough information in one triangle to work something out, which will be part of the next triangle. I'm seeing a right-angled triangle here with a known angle and a side, which means we can use that information to find another side of that triangle. Notice how the side AB is part of both this smaller triangle and this larger triangle. So let's find AB using the angle 41 and the side AC, which is 35. Now, from this angle, 35 is the adjacent, and the side AB is the opposite, so we can use tan to find that side. We'd have tan of 41 degrees equals side AB over 35. We'd solve for AB by multiplying by 35. So AB equals 35 times tan of 41. So we get 30.43 centimeters. I'm taking some extra decimals to help with the accuracy of the next answer. So now that I know this side is 30.43, I can use that side and this hypotenuse here of this larger triangle to find theta. So from the angle theta, this side is the opposite, and this is the hypotenuse. So we're going to use sine. Sine theta would equal opposite, 30.43, over hypotenuse, which is 93. To get theta, we do inverse sine, of 30.43 over 93. We've got 19.099 degrees. Remember, it wants it to the nearest minute. So we're going to convert that. That's 19 degrees, 5 minutes, and 57 seconds, which is closer to the next minute. So we'll say 19 degrees and 6 minutes. Okay, question 27. A company purchases a machine for $50,000. The two methods of depreciation being considered are the declining balance method and the straight line method. For the declining balance method, the salvage value of the machine after n years is given by the formula S equals V naught times 0.80 to the power of n, where S is the salvage value and V naught is the initial value of the assets. What is the annual rate of depreciation used in this formula? So, the declining balance formula is on the reference sheets. This formula here is the declining balance method of depreciation. You can see inside the bracket is 1 minus R. R is the rate of depreciation. So if we look at what we have here, inside the bracket is 1 minus R. Now, if that's equal to 0.80, then R would equal 0.20, as in 1 minus R is essentially 80%. 1 is 100%, and 100 minus 20, of course, is 80%. But if you're unsure about getting that, you can always solve the equation for R. So we can also write that R is 20%. Now, in the next part, calculate the salvage value of the machine after 3 years based on the given formula. So salvage value is equal to initial value, in this case 50,000, times 0.80, which again is equal to 1 minus R to the power of n, in this case 3 years. We'll want to use the calculator, of course. So that's $25,600. Now for part B, for the straight line method, the value of the machine is depreciated at a rate of 12.2% of the purchase price each year. So that's different to declining balance. It's not 12.2% of the current value at each year, but of the original purchase price, which is a constant amount. So we want to work out what is 12.2% of the initial value, which again was 50,000. We'll multiply. That is $6,100 of depreciation per year. Now, when will the value of the machine using this method be equal to the salvage value found in part A2? So if we go to our reference sheet, we can see this straight line method as well. S equals V naught minus dn. Remember that S salvage value, V naught initial value, D is the depreciation per period, and N is the number of periods. And they want to know when the salvage value is equal to that found earlier, which is the 25,600. V naught is 50,000, of course. Depreciation per period, 6,100 times N. That's what they're asking us for, as in when, as in time. So this is an equation, and we can solve for N. First, we'll subtract 50,000. So this will come out negative for a moment. But that's because on the right-hand side, we're left with negative 6,100 n. So when we divide, it will become positive. So we solve and we get n equals 4. Question 28. A dam is in the shape of a triangular prism, which is 50 meters long, as shown. Both ends of the dam, ABC and DEF, are isosceles triangles with equal sides of length 25 meters. The included angles BAC and EDF are each 150 degrees. This is also a 4-mark question, which means it's going to have a bit going on. So, we need to calculate the number of liters of water the dam will hold when full. So, we're going to find volume first in cubic meters, and then we can get liters. Now, to find volume, we take the approach that volume is the area of the base of a prism times the height of that prism. We don't have that on the reference sheet, although you may spot in the formulas for volume, this one here is the volume for a pyramid or a cone. If you remove the fraction AH, that's the formula we're working with. So prisms and cylinders, just A times H. Put the 1/3 in front, multiply by 1/3 to get pyramids and cones. So this is a triangular prism. To find the volume, we have to find the area of the triangular base, which we see in the front here. Now there's 2 ways to find the area of a triangle. The classic area equals 1/2 base times height. We can use that when we have a base and a height. In this case, we actually don't have that information. The other formula we learn in year 12, which is A equals 1/2 AB sine C. And we use that when we have 2 sides and an included angle. The angle will be C, and we can find the area of that triangle. That's the setup we have here. So, if you need it, that formula is on the reference sheet. Under trigonometry, you'll see that here. But the original area of a triangle that we learn in year 7 is not there. Make sure you memorize that one. So here our area will be 1/2 times A times B. Those are the 2 sides that form the angle we're going to use. Now this is an isosceles triangle and they're both 25. And then times sine of angle C, the included angle, that is the 150 degrees. So we'll calculate that. We get 156.25 square meters. That's the area of the base of the triangular prism. The volume is that times the height of the prism. In this case, it's the 50. So volume is 156.25 times 50, which is 7,812.5 cubic meters. Now, we might need to know then the conversion between cubic meters and liters. So make sure you know that 1 cubic meter is 1 kiloliter, which, as you know, is 1,000 liters. So to convert this to liters times by 1,000, that's 7,812,500 liters. Question 29. Sydney is 10 hours ahead of Coordinated Universal Time, which is UTC plus 10, and New York is 5 hours behind Coordinated Universal Time, UTC minus 5. Tony travels from Sydney to New York. His plane leaves Sydney at 8:20 p.m. on Wednesday local time and flies nonstop to New York. The flight takes 20 hours and 24 minutes. What time of day is it in New York when the plane lands? So, sometimes when I'm dealing with these kinds of questions, I like to draw a little number line to help keep track of how far apart things are and in which direction. So Sydney is 10 hours ahead, positive 10 plus 10 comes over here on the right, just like a regular number line. And UTC minus 5 for New York is over here on the left, minus 5. You can see that they are 15 hours apart. So if you're traveling from Sydney to New York, you would be going to the left, which means you'll subtract the 15 hours to convert to that time zone. So starting with the departure time of 8:20 p.m. on Wednesday, we will subtract 15 hours to convert to New York time. So 15 hours before 8:20 p.m. If we took away 12 hours, it would be 8:20 a.m. And then 3 more hours is 5:20 a.m. on Wednesday. But let's not forget to add the travel time. So we now have to add 20 hours and 24 minutes. So if it's 5:20 a.m. in 20 hours, it will be 1 a.m. the next day. And adding on to the minutes, 20 minutes plus 24 minutes, that is just 44 minutes. So it's 1:44 a.m. the next day, Thursday. Okay, question 30. Eli is choosing between 2 investment options. Option 1, depositing a single amount of $40,000 today, earning interest of 1.2% per annum compounded monthly. We see that single lump sum investment. That is a regular compound interest investment where we would use the compound interest formula. Option 2, depositing $1,000 at the end of each quarter, earning interest of 2.4% per annum compounded quarterly. Now we should recognize that as an annuity because we're depositing an amount on a periodic basis with compound interest earned on that same periodic basis. We have a future value interest factor table for annuities. And then the question says, what is the value of Eli's investment after 10 years using option 1? So, as I mentioned, option 1 is a single lump sum investment. We're going to use the compound interest formula. Remember that that's this one here. FB equals PV times 1 plus R to the N. So if we invest $40,000, interest rate 1.2% compounded monthly. So beforehand, we could divide that interest rate by 12 because there's 12 months in a year. Or we could put the percentage into the formula and just put it over 12. Whichever you prefer is fine. N number of compounding periods, that's 10 years, but it's monthly, so we could work out N 10 years times 12 months per year, that's 120. Or we could just put that even into the calculator to do for us. So we'll get a future value of $45,097.17. Part B, what is the difference between the future values after 10 years using option 1 and option 2? So, well, we've already worked out option 1. Let's work out option 2. which is an annuity. It's an annuity of $1,000. Quarterly, 2.5% per annum, so we'll have to convert that to quarterly. There's 4 quarters in a year, of course. So that would be 0.6% per quarter. And number of periods, as in this case, quarters, 10 years. 4 quarters per year. That's 40 compounding periods. So in the table, we're looking at this number, this percentage, this R here, that is equivalent to 0.6%. You could check that in your calculator if you need to. And to get the future value of an annuity using a table, future value is the contribution times the number in the table. So in this case, it will be the contribution, $1,000 per period, times 45.05630. That would come out to $45,056.30. And they're asking for the difference. So that would simply be $40.87. Question 31. A wildlife park has 5 main attractions, A, B, C, D, E, connected by directional paths. A simple network is drawn to represent the flow through the park's paths. The number of visitors who can access each path at any one time is also shown. What is the flow capacity of the cut shown? So to calculate flow capacity, we will add up all of the edges that go from the source side to the sink side of the shown cut. So the source side, of course, is this side over here, and the sink side is this side over here. So the edges that we will include will be the 10, 20, and this 10 here. We would not include this 10 here because it's going from the sink side to the source side. So it's going to be 40. Now part B, by showing a suitable cut on the diagram below, explain why the network's current maximum flow capacity is less than 40 visitors. Now, it's not asking for the maximum flow, but we do know that by the minimum cut maximum flow theorem, that the maximum flow cannot exceed the minimum cut. So as long as we do find a cut that is less than 40, that means the max flow itself would have to be less than 40. We can see here that there is 40, so we need something smaller than that. If we cut perhaps through here, we have one that's going the wrong way, which wouldn't count, and we have 15, 10, and 10, and that adds up to 35. So that cut will suit our needs to total something that's less than 40, and it may not be the minimum cut, but since the maximum flow can't exceed the smallest cut, if this is less than 40, then the max flow is less than 40. So the cut is 35. We just need to show the cut. And the explain part is to mention the minimum cut maximum flow theorem. Now the next part says, one path is to be increased in capacity so that the overall flow will be 40 visitors at any one time. Which path could be increased and by how much? Now, the minimum cut, or at least a cut that is less than others, will give you an idea of where you may have a bottleneck in the system, right? It gives us areas to check. So if we do check the edges passing through to different vertices. So maybe if we check the ones coming in and out at vertex E, I see that we have 25 coming in and we have 30 going out. So that one seems okay for now. It could actually take more in. Let's check other areas, see if we can identify something that has a bigger problem. Let's look at B. B has 20 coming in and 30 going out. So again, that could actually take more coming in. And then let's go and check D. So D has the 20 and the 10 coming in here and here. That's 30. And it has 30 going out. So that one seems okay. If we look at A, I'm seeing 20 coming in and 15 coming out. Now remember what we noticed, that E could take a little bit more because it can push 30 out. So only having 25 coming in means it could take in 5 more. And at A, we have kind of the opposite problem, 20 coming in, but only 15 can leave. So if we increase that edge there by 5, both the in and out at A and E will be increased. And what's good to see too is those are both connected to the source and the sink. So we know that's going to get like all the way through. So if we increase this edge to 20, then we can increase our flow through by 5. So we'll write to increase AE by 5. Question 32. The diagram shows a park consisting of a rectangle and a semicircle. The semicircle has a radius of 100 meters. The dimensions of the rectangle are 200 meters and 250 meters. A lake occupies a section of the park as shown. The rest of the park is a grassed section. Some measurements from the end of the grassed section to the edge of the lake are also shown. So, we're going to use 2 applications of the trapezoidal rule to calculate the approximate area of the grass section. Alright, so trapezoidal rule, there's a formula on the reference sheet, and it's this one here. The area will approximately equal h over 2 df plus dl. df and dl are the parallel sides of each trapezium. So the first one we're going to look at might be this one here. I'll call this area 1. The area would approximately equal the height. Now, a lot of times the way this is oriented, the height is more like the width of the trapezium. Notice that the whole rectangle is 20 meters wide, but each trapezium is equal in length, so that's just cut in half. And the height here is 100 for each trapezium. The parallel sides for this one are 160 and 150. So that area is about 15,500 square meters. Now if I call this one area 2, we're going to get approximately 100 over 2. And the parallel sides here are the 150 and the 250. So that's about 20,000 square meters. So the entire grass section would be the sum of those two, 35,500 square meters. Part B, hence calculate the approximate area of the lake to the nearest square meter. So if we look at that diagram again, we need to look at the bigger picture here. We have a rectangle and a semicircle, and the lake is basically everything but the grassed section, which we just approximated. To get the approximate area of the lake, we're going to find the area of that entire shape, rectangle plus semicircle, and subtract the area we found in part A. So the rectangle there is 200 by 250. And the semicircle has a radius of 100. So we can use pi r squared, pi times 100 squared. And we need a half circle, so we could throw in divide by 2, or you could times by a half. So that is 65,707. Let's round to 708 because we're going to get near a square meter in the end anyway. And the next thing we're subtracting is an approximation, and it is to the nearest whole number anyway. So that is the entire area. So the lake is just going to be that minus 35,500 from part A. So we get 30,208 square meters approximately. Question 33. The diagram shows an airplane that was flying towards an airport at A on a bearing of 135 degrees T, as in a true bearing, when it was at point O, 20 kilometers away from the airport at A. The flight course was changed. The airplane landed at an airport at B, directly south of O. The distance from O to B is 50 kilometers. So they have put the 50 kilometers and 20 kilometers on the diagram. Notice, though, that that bearing is not on there. We're going to have to add that on ourselves. So show that the distance between the airport at A and B is 38.5 kilometers to one decimal place. Let's put that bearing on there so we have an angle to work with. So that bearing is going to be drawn at O, where that north arrow is conveniently. So let's put 135 there. That would be from here to here. Okay, remember that B is directly south of O, so we could take that angle inside that triangle as 180 minus 135. Okay, so we have 45 degrees here. All right, now, don't make the mistake of assuming that this is a right angle triangle because we don't have that information. We're not given that there's a right angle here. So let's assume it's not. And we won't be able to use regular trigonometry, but we could use cosine rule here, right? So the cosine rule on the formula sheet, this one here for finding a side, it's a lot like Pythagoras, but with that extra bit on the end, the minus 2ab cosine c. We'll have c squared equals a squared plus b squared minus 2ab cosine angle c. Now in this case, the angle c is going to be the 45 degrees. A and b are the two sides that go around that angle, that form that angle, so that's the 50 and the 20. So the side we're trying to find, squared, equals 50 squared plus 20 squared. Remember, those two, the A and the B, the order doesn't matter, which one's which doesn't matter, but angle C has to be between them. So 2 times 50 times 20 times cosine of 45. Now, don't forget, there is one more step here. This is what c squared equals. C itself will be the square root then. So that is 38.5 kilometers, which we were told it was going to be. Part B, use the sine rule to find the angle OBA to the nearest degree. So angle OBA is this one here. And it says do the sine rule. So that angle is across from that 20, there. And we now know side AB is 38.5. So that can be paired with the angle we know already, which is 45. Now sine rule, also on the reference sheet. Sine rule is this one here. They have the one version because if you want to find an angle, you just flip it upside down so your angle stuff's on top. So we'll have sine theta over its opposite side, which is the 20, equals sine 45 over its opposite side, which is the 38.5. Solve for sine theta multiplied by 20. So we'll calculate that real quick. That's going to be 0.367 and lots of digits. Don't forget, there is one more step to do because we're trying to find the angle, which I called theta, not sine theta. So to get theta, if we know what sine theta equals, we take inverse sine of the answer. That's going to be 21.55 degrees, rounding 22 degrees. Lastly, what is the bearing of the airport at B from the airport at A? Note the location that we are doing the bearing from. It is from airport A. That's where we draw the bearing. Okay, so we're going to draw a north arrow where we need the bearing. We're going to draw an arc until we point to our destination, which is airport B. So that's going to be this arc here, right? If we knew what, say, this angle in here would be, and this angle out here would be, we could take those away from 360 to get the bearing that we need. There is enough information to do that. First, let's look at that top angle. I'm going to use co-interior angles. I've got the 135 here. This angle over here is co-interior because those north arrows are parallel. So that's going to be 180 minus 135, which is 45 again. I could have used alternate angles as well. You get the same thing. Now that angle in the triangle we can get because we worked out that angle down here. Remember, that was the approximately 22 degrees. And the angles in the triangle add up to 180. The angle we're looking for is 180 minus 45 and minus 22. So 113. And so the angle for the bearing will be 360 minus those two angles. (202 degrees). Don't forget that bearings need to have 3 digits. If this came out to a 2-digit angle, don't forget to write a 0 in front of it. Question 34, another 4-mark question. So again, there's going to be a bit of working out to do here. A composite solid is shown. The top section is a cylinder with a height of 3 centimeters and a diameter of 4 centimeters. The bottom section is a hemisphere with a diameter of 6 centimeters. The cylinder is centered on the flat surface of the hemisphere. Find the total surface area of the composite solid in square centimeters correct to 1 decimal place. Okay, surface area. So, let's start with the cylinder. The surface area for a cylinder is on the formula sheet. So that is this one here. Hopefully you recognize it and know what those two parts are. This first part is 2 circles. The second part is the rectangular curved surface that goes around to form the cylinder. Now, there's going to be different approaches that can be taken to find this surface area. I'll take the more obvious approach. Okay, I've got a cylinder, right? The cylinder, I have, of course, the cylindrical part. I've got that circle on the top, but that circle on the bottom is not part of the surface area because it's like glued to the hemisphere and it's now inside the shape. So I can modify the surface area of a cylinder formula. Instead of 2 pi r squared, we're going to just make it a single pi r squared. So we have one external circle on the surface plus the 2 pi rh, which again is that rectangle that wraps around to form the cylinder. So that's going to be pi times the radius squared. Careful here. We're given the diameter of the cylinder being 4. That means the radius is 2, which is half the diameter. And the height of the cylinder there is 3. We'll take some extra decimal places till the end just to add accuracy, and we'll round our final answer. Okay, now our hemisphere, sphere, surface area is also on the formula sheet. That's this one here, 4 pi r squared. It's a half sphere, so we're going to maybe have that. Now be careful with that because we just get the outside of the ball shape only, and when you cut that sphere, you now have more surfaces, some flat surfaces where it's been cut. So when we do this, we're going to get only the bottom round part of the hemisphere. I'll add divide by 2. You can also instead just times by a half. The radius of the hemisphere is 3. We're given the diameter being 6, so the radius is half of that, which is 3. So that's about 56.549. Okay, there's one more surface that we have not included yet, and that is this ring around the top of the hemisphere. It's called an annulus. Essentially, if we looked at the top down, it would look like that, and essentially all it is it's a circle minus a circle. And so we're just going to use the area of a circle, pi r squared. So that outer circle, part of the hemisphere, radius 3. Inner circle is because of the cylinder, radius 2. So about 15.708. Okay, total surface area, that is everything. So we just need to add those 3 things up. And we'll round to 1 decimal place. So that's how you can find that surface area. Again, there are different approaches. Okay, so a shortcut way to work out the surface area would be to just find the rectangular round part of the cylinder and ignore that top circle because you can include that top circle as part of the top of the sphere. So if you don't include it as part of the cylinder and include it instead as part of the top of the sphere, you could just do 1 circle calculation there at the top and then the hemisphere round part, add that to that outer part of that cylinder, and that's a little simpler, but you're going to get the same answer anyway, so it's okay if you don't do it that way. Whatever works is fine. Question 35, another 4-mark question. So Joe is researching the relationship between the ages of teenage characters in television series and the ages of actors playing these characters. After collecting the data, Joe finds that the correlation coefficient is 0.4 0.4564. A scatter plot showing the data is drawn. The line of best fit with equation y equals minus 7.51 plus 1.85x is also drawn. Describe and interpret the data and other information provided with reference to the context given. All right, so this is a describe and interpret question. It's 4 marks, which means we need to point out 4 key features about this data set. So we could start with the correlation coefficient, 0.4564. It's not very strong. It's positive. So we could say something like there is a weak positive correlation between age of character and age of actor. This means the higher the age of the character, the higher the age of the actor tended to be. Now, let's bring the equation of the line of best fit into it. The most important part here is going to be the gradient. This is an example where the y-intercept doesn't have a lot of meaning here. That's especially true when the data goes nowhere near the value when x would be 0. And the fact that it's negative, again, age would not be negative, so it doesn't make a lot of sense. We definitely can talk about the gradients. The intercept may not always be meaningful. The gradient always will be. So what the gradient tells us is more specifically about that, relationship. The older the character, the older the actor. It tells us specifically like how much older they tended to be. So we could say, according to the line of best fits, the age of the actor was on average 1.85, getting that from the gradients, years older, for every 1 additional year of age of the character. Lastly, there's one more thing that we can point out about this relationship, and that comes to validity, right? The data only exists for ages of characters from 14 years to 17 years old. And that's again why, if we thought about the y-intercept, first of all, that would be what we call extrapolation. That's outside of the data. And also why we're getting something weird like negative 7 years old, right? So we would mention that the trend is only valid for characters years 14 to 17, or something to that effect. So that should be enough to get 4 marks. We noted that it's positive. We noted that it's weak. We noted that the gradient 1.85 gives us a numerical value for increase in age of actor for age of character, and also the validity of the model as well. Question 36. Frankie borrows $200,000 from the bank. The loan is to be repaid over 23 years at a rate of 7.2% per annum, compounded monthly. The repayments have been set at $1,485 per month. The interest charged and the balance owing for the first 3 months of the loan are shown in the spreadsheet below. What are the values of A and B? So this is what we call a reducing balance loan. And so we track that in a spreadsheet or a table month to month. We're missing the value A, which is in the interest charged column. Now, interest is 7.2% per month, compounded monthly. So to work out that interest for that month, we're going to need to convert that to a monthly interest rate. So 7.2% divided by 12, that's going to be 0.6% per month. And so if we find that percentage of the principal at the beginning of that month, we'll get the interest charge for the value for A. And so we'll do the principal times 0.6%. $1,198.29. Then B is the balance at the end of that last month. So your balance is going to be your original principal at the beginning of the month. We're going to add interest, but then we're going to subtract our repayments. We add that and subtract that. So at the end of that month, we'll owe $199,139.86. Part B. After 50 months of repaying the loan, Frankie decides to make a lump sum payment of $40,000 and to continue making the monthly repayments of $1,485. The loan will then be fully repaid after a further 146 monthly repayments. How much less will Frankie pay overall by making the lump sum payments? So let's work out how much Frankie pays altogether in this situation. So Frankie has paid 50 months of payments of $1,485, a $40,000 lump sum, and 146 further monthly payments of $1,485. So that's $331,060 repaid. Let's compare to the situation where she doesn't make a lump sum payment. The loan is for 23 years. So Frankie would pay 23 times 12 payments of $1,485. $409,860. So by making the lump sum payment, she's paying less. That's because she's saving a lot of interest. So the amount she saves will be the difference. So $78,800 saved. Question 37. The lifespan of batteries from a particular factory is normally distributed with a mean of 840 hours and a standard deviation of 80 hours. It is known from statistical tables that for the distribution, approximately 60% of the batteries have a lifespan of less than 860 hours. What is the approximate percentage of batteries with a lifespan between 820 and 920 hours? Okay, the first thing I'd like to do is draw a normal distribution. Mean 840. Standard deviation is 80. So if we add 80 onto 840 a couple times, we can fill out the normal distribution. And then on the left, we can subtract 80. Okay, now it's asking what percentage would be between 820 and 920. So 920 is one of our common z-scores that we're going to see on the normal distribution. However, 820 is not a z-score of 1 or 2 or 3, right? So that information there in the middle of the question is going to help us to figure out something about that. So when it says it's known that 60% of batteries have a lifespan of less than 860, that means from this point here, 860, everything below that is going to be 60%. Now, when we're looking for 820, that's going to be below 840. And notice how that's symmetrically below 840 because, 860 here is 20 above. 820, of course, is 20 below the mean. And so we're going to use symmetry here to work out the percentages around this. So there's different approaches we could take. What I'm going to notice is that with the 860 and below, if that's 60%, then above that is 40%. And so symmetrically then, if it's 40% above 860, it would be 40% below 820. Now we just need to work out how much it is from that point up to 920. So let's focus on that. So we're going to try and get this information in between. So 920, right, is on the reference sheet because that is one standard deviation above the mean, the z-score of 1. Okay, and we're told that in between here and here is 68%, which means outside of that is going to be 32%. And these tails here and here, and it's symmetric, so each side of that is 16%. We're going to use that. So once again, up here is going to be 16%. And so now I can more easily find what's between 820 and 920. Because to the left of 820 is 40%, and to the right of 920 is 16%. So inside of that is going to be 100% minus the 40 and the 16. So we're going to get 44%. Okay, question 38, last question. It's a ratio question. So that's going to scare a lot of students. Once you see how it works, though, it's not actually that bad. So we have a full container, 4.8 liters of a mixture of cordial and water in the ratio 1:3. After removing 1.2 liters of the mixture, more water is added to refill the container. What is the ratio of cordial to water in the final mixture? So let's first work out how much we have of each, as in originally, if the ratio of cordial to water is 1:3, how much in liters is that? So it was 4.8, but we poured 1.2 out, so that leaves 3.6 liters in the ratio 1:3. So we need to split that 3.6 liters into that ratio. With ratios, what I like to do to demonstrate them is to draw a box for each part. So on the left, on the cordial side, we have 1 box. On the right, on the water side, we have 3. All we have to do is split or divide the 3.6 liters that's in there into these 4 parts equally. So that's 0.9 liters per part. I just fill that into the boxes. So of course you have 1 lot of 0.9 on the left, 0.9 liters of cordial, and 3 lots of 0.9 on the right. Now 0.9 times 3 is 2.7. Okay, so now we know exactly how many liters of each thing we have. Now it says we're going to be adding straight water back in. And remember, we poured 1.2 liters out, so we're going to be pouring then 1.2 liters of water only, into the mixture. So now we're going to have a new ratio. We're adding 1.2 just to the water side. So the new ratio is going to be 0.9 to 3.9. Okay, that is technically the answer. We don't usually leave ratios in a decimal format, so we might convert. If you times these both by 10, perhaps, you would get 9 to 39. You could even simplify this, divide by 3, and you'd get 3 to 13, and that's the new ratio of cordial to water. And that's it. So thanks for watching. I hope it helped you a little bit in your study for the HSC. If there were any mistakes in there, feel free to drop a comment because everyone makes mistakes when it happens. If you have any questions about how we work things out, feel free again to leave a comment. Anyway, don't forget to like and subscribe. We'll be putting more videos, explanations, HSC work solutions up there for everyone to help them study. All right, and have fun studying and good luck on your tests.